Next problem. A diatomic molecule is made of two masses m1 and m2 which are separated by a distance r. If we calculate its rotational energy by applying Bohr's rule of quantization of angular momentum, its energy will be given by. Okay. Now we know that if it's a diatomic molecule having different masses m1 and m2, then the rotation would take place about the center of mass of these two bodies. Let us say the distance from mass 1 is r1 and from mass 2 is r2, and the total distance is r. Then we know that m1 r1 will be equal to m2 r2, and r1 plus r2 is given as r. So we can find out the value of r1 as m2 upon m1 plus m2 times r, and the value of r2 as m1 upon m1 plus m2 times r. Okay, so this we have found out. Now when it is rotating about the center of mass having radius r1 and r2, the total energy, that is kinetic energy, will be given by half I omega square. Now the value of I will be given by m1 r1 square plus m2 r2 square. Now which can be further written into as m1 m2 squared r2 squared upon m1 plus m2 whole squared plus m1 squared m2 r squared upon m1 plus m2 whole squared. Okay, now this can be, we can take m1 m2 r square upon m1 plus m2 whole squared as common, and we will get m1 plus m2. This will cancel out this expression, so the moment of inertia I is given by m1 m2 upon m1 plus m2 r squared. Okay, this term is also known as the reduced mass. Now we have to apply Bohr's principle of quantization of angular momentum. That means angular momentum L, which is given by I omega, is equal to nh upon 2 pi. Okay, so the value of omega is nh upon 2 pi times I. Now if you substitute the value of omega in this expression of kinetic energy, rotational kinetic energy, we will get kinetic energy which is equal to half I omega square will be equal to half I times n square h square upon 4 pi square I squared. So this will cancel out, and we will get the value of k as n square h square upon 8 pi square times 1 by I, and the value of I we already know, we have calculated. So it is n square h square upon 8 pi square, and the value of I is m1 m2 upon m1 plus m2 times r square. So the correct expression for this is n square h square upon 8 pi square r square m1 plus m2 upon m1 m2. Okay, so from the 4 options that are given, the option